Good morning, everyone. Welcome to the HPC in the City St. Louis Hackathon, Google and Cloudy Cluster training session. So this session is the third in our series of training sessions. We actually have two more coming up. So we had our mentor training. Last week, we had our GitHub and Discord training. And today, we're going to focus on two of our major HPC resources, that being Google Compute Platform and Cloudy Cluster. And one of our fine organizers, Mr. Boyd Wilson, will actually be leading the charge there. But before we do that, let me make sure this is gone so that you don't see that. I said, make sure you're gone. You got to love notifications. They always come when you don't need them to. So let me make sure that's on Do Not Disturb until the evening. There we go. All right. So our agenda today, we're going to do some brief introductions. We're going to go over our hackathon objectives, deliverables, and resources, some general information, and then we're going to jump into not Discord basics and GitHub. Jamie, you should have checked your slides, but we're going to go into Google and Cloudy Cluster. Now, our organizers, I would be remiss if I didn't, of course, speak of them today. You're going to hear from at least three of us today, which is pretty interesting. But starting in alphabetical order, Mr. Alex Nolt. It's actually from the University of Tartu, so he's actually overseas. He is our hackathon specialist. We have Miss Amy Cannon from Omnibond, who has always been the heart of the hackathon. So we've had worked with her since the very beginning. Mr. Boyd Wilson, who we'll be hearing from today, who is the CEO of Omnibond, and he's the one, like I said, he'll actually be telling you about the product that his company has created and innovated with over the years. Myself, Jimmy Powell, I'm your host, and then Dr. Linda Hayden from Elizabeth City State University, my mentor, and the representative from SGCI, and one of the initial people that came up with the idea for us to have these types of hackathons. So organizing committee, I know Dr. Hayden's here. Dr. Hayden, would you like to say hello to everyone?
Yes.
Oh, we heard you say yes. There you are.
Hi, hello everybody. Welcome to our training event. Hoping that this is very effective in helping you to prepare yourself for the exciting hackathon that's about to happen. We're looking forward to working with you, and I just encourage you to continue to join our training sessions and to enjoy each and every one of them. Bye-bye.
Excellent. Thanks, Doc. Now, Boyd, I know that you're going to be presenting here, but do you want to say hello really quickly?
Hello, how's everyone doing? So yeah, you'll hear from me in a minute.
Excellent. A man of few words. No, I'm just kidding. He'll be giving the presentation.
Gotta save him up.
So now the objective of HPC in the City St. Louis is to use the hackathon format and to bring together both the resources from the high performance computing HPC community, the skills and knowledge, along with students and researchers and those that are members of the community, to address problems that directly affect the participants. And even more so, problems that directly impact, in this case, the St. Louis and even greater Missouri area. They're going to develop knowledge about solutions to identify issues affecting St. Louis through the application of data analysis, presentation, or management. Some of the outcomes that you're going to have as participants, especially students, you're going to have an increased familiarity with data science in the cloud. Of course, we're going to learn about two of those resources today. You're going to work with collaborative software engineering, which is a very interesting thing if you've never done it. And of course, you're going to develop those professional communication skills as you present your findings on November 8th. Now, the deliverables that each and every team will be giving or will have available for us on November 8th will include a GitHub repository that includes your source code with comments. Comment your code. Be a good citizen of software. Comment your code. A PDF of the presentation you're going to give. Inside of that presentation, you're going to make sure you have pictures and names of the people on your team. You're going to explain how you used HPC technology to complete your project and the direct regional implications of that project to St. Louis in this case. You're going to create a readme.md, so a readme.markdown file with a project description as well. If you want more information on that particular topic, last week's training session, which is available on hackhpc.org /HPC in the city, we went over how to create a GitHub repository using the web GUI. And we also showed you a couple of examples. Some of the resources that you're going to have available, two that you're using today, the Google Cloud platform, which Google has so graciously donated credits to the hackathon for you to use, which is amazing. Cloudy Cluster, which Boyd is going to give you a lot of good information on using. Some of the more commonly used software applications and things include Python, Jupyter Notebooks, Node.js, Replit for that collaborative programming, and of course, HTML, among many others. I do want to put a huge push out there for you. If you have not yet joined our Discord, what are you doing? Join the Discord. The Discord is our method of communication wherein our teams can communicate, our members can communicate with the mentors and things like that. Join the Discord. That's where we're going to put the most exciting news. And that, of course, is our main way to communicate back and forth. And I see somebody just took me up on that. Thank you and welcome. So some general information, 3 T's. Teams. Teams. I know some of you are all saying, I just signed up for this thing. I don't have a team. And that by far is the mass majority of you all. The night of the kickoff, we're going to have our mentors do some presentations. Basically 1-minute lightning talks to say, please help me with my project. Help me with this particular thing. And as you're sitting there watching that, you're then going to be able to choose what project you want to work on. And that's when the teams will be formed. Now, our teams, we do limit them to a maximum of 5 students. We usually suggest you have about 4. That seems to work best, but a maximum of 5. Each team will also have a primary mentor and then a secondary co-mentor or specialist that will assist your team. As far as in time, starting November 4th through the 8th is when the main event kicks off. We have our kickoff that night on the 4th at 6 p.m. Eastern, which is 5 p.m. Central. And during that time, we'll actually have our team formations and things. The 5th through the 8th, we'll have these things called check-ins. We'll have one in the morning and one in the afternoon. And what those check-ins will allow us to do is to, one, we'll be able to make sure that your teams are on track. If there are any issues, any ways we can help keep you moving. And second of all, we throw some surprises in there. Any of you all that participate in our hackathons, you may want to ask them because we do stuff. So we have little mini competitions to keep it fun. And then of course, on the 8th, you invite your family and friends to come and to view the final 10-minute presentations on that day. Some of the topic examples include data analysis of COVID-19, economic disparities, social justice issues, broadband access, insurance, AI-based crowd status, which is a very interesting project, which you may be hearing more about, not next week's training, but the training following that from one of our student mentors, graduation rates, weather modeling, genomics, and the list goes on and on and on. Again, if you have an idea for a project, there's still time for you to be one of the people to present a project as well to see if people want to join you in working on it. You can be a student mentor as well. If you would like to do that, just send me a message on Discord or email me directly, and we'd be glad to get you going. Having said that, I get to be quiet now and hand the floor over to Mr. Boyd Wilson, who will now tell us a bit more about Cloudy Cluster and the Google Cloud Platform. Now, Boyd, what I'm going to do is I'm going to escape out and I am going to stop my share. And I will hand the floor over to you. You have our attention.
And the mic and the floor. Is my audio okay? Josh said I was coming in real hot before.
Sound good?
Okay. I switched mics. Okay, excellent. Everyone see my screen okay?
Yes, looks good.
Great. As Jamie so wonderfully introduced and such a good public speaker, it's really a pleasure to be part of the hackathon every year. And so we're looking forward to that. I just want to give a little bit of background of Omnibond. We actually have a lot of experience in higher education and research computing. I won't go through all this stuff, but we really care about the educational process and learning and growing the capabilities in areas that the world needs to make this place a better place to live in. I'm going to get straight to it. One of the things I want to start with is just going over the Google Cloud Console. And what you'll get at the hackathon is you'll get some projects already created. And let me get to my console screen. And when you log into the Google Cloud Console, and what we'll do is you'll give us a Google account, and we will set it up after you set up your teams to have access to a specific project that your team has access to. Google has been wonderful in giving us credits for this. And so we'll have this all kind of staged and set up for you. One of the reasons, just to give a little background, that we set up these projects for you in a specific account that already exists is because of limits. One of the things when you go out and create your first Google account, and I would recommend if you want to play with this to go ahead and do that, because you get like $300 worth of credits to play. The one thing to remember about the cloud, though, is it's a pay-to-play situation. So when you're launching something, creating something, storing something, you're paying. It may seem like a little bit, but if you leave it there for a long time, then it becomes a lot of little bits added up over time, and you can burn through your credits. And you can burn through them more quickly if you run things like GPUs, but we'll get to that in a second. But it also can cost almost nothing to do things that you normally can't do, and that's why the cloud is caught on, especially for startups and small companies and things like that. So it's actually kind of an exciting time to, over the last decade, to see the cloud kind of become as predominant as it has. So the one thing to think about the cloud is if you think about a computer and you want to spin up a computer, say I want to go down to the store, buy a computer, set it up on my desktop. If you want to do that in the cloud, a credit card has already been associated with this. So everything I do, we will be paying for. But you go to something called a VM, a virtual machine. You've probably heard that term. So to get to the virtual machines, you go down under Compute Engine, Computing, and we'll go there in a second. There's also data store and cloud storage. We'll kind of go over these, but this is kind of all the different things at a high level you can do in the cloud over here on the left. And we'll be going over some of those. You can explore, and I'll give you some ideas of how to explore and explore for free, potentially, if you're willing to fill out some forms. Not my forms, but Google's and other forms. So anyways, let's go to the compute engine, just look at VM. We'll kind of go down the concept of spinning up a computer. So there's already stuff running in this project because I launched stuff ahead of time, but an instance and a VM are the same thing. So if you want to create a VM, you click on Create Instance. And again, this will just give you a computer in the cloud, a Linux computer. You could do Windows or something, but we're going to do a Linux one. And you give it a name. And I'm from the South, or I hit a key and you lose everything. The back button does work. So we'll just call this Baba because I live in the South. And if you'll notice, there's a region. So all of the clouds, including Google, you have these different regions. And actually, they have these places where you can run stuff that actually even are a little more green than others. So they tell you that now. That's actually a cool new add-on that I have not seen. And so, let's do it in central Iowa, okay? And it's a low CO2 region. And then within that region, there's different what I'll call data centers. So you could choose which data center in that region you want. So this is a building with a whole bunch of computers in it, and you're going to go say, I want a little tiny slice of that. Let's do F, since it's the last one. And the last one is always the most recent. That doesn't mean they have the most recent technology, but that's the most recent one as they add them. And then you have these two options here, your machine family, compute general purpose or compute optimized. And we'll just stick with general purpose. And then you get to choose the various different types. And so these are kind of the E2s, the N2s, N2Ds. So you have the Cascade Lake if you want the N2s. Let's go do a Cascade Lake just because it's a good one. And then you get to choose how many vCPUs. Now, if you remember from your computer architecture class, if you took one, if not, there's this thing called CPUs. And many years ago, you got one CPU in your computer and you were happy. Even your phone has more cores in its CPU, so they call them vCPUs now than what we used to have many years ago. But so you can choose how many of these virtual CPUs. And a virtual CPU from your computer architecture class equals to a hyperthread. A hyperthread is just a way to divide up work in the CPU. And so you can choose anything up to 80 CPUs in this N2 category. Some of the other ones let you more. We'll just choose a 2. And this is just general how to do stuff in Google Cloud. We'll get to Cloudy Cluster in a minute, which automates some of these things for you and it makes you, do things a lot more quickly. But I just want you to kind of understand what the cloud provides for you. And then you can set up some other options. And one of them is, your boot disk, how big a boot disk do you want and what image do you want? And so this is just a standard Debian Linux image. It's kind of the default you choose. And then you will set up, and it's set up for 10 gigabytes. And then if you're launching it, you generally just choose the service account that you normally use. A service account is kind of a security principle within Google Cloud. And if you're running in your own project, you can generally take the defaults. We'll get into a little bit more of that later. And then the access scopes is really, is this thing going to need to be able to run APIs? Is it going to do things like that? But if you're just spinning up a VM to run something on, default access is fine. And this is your firewall rules. You can go in and set custom firewall rules down here. But if you want to spin up a web server, you're probably going to want HTTP and HTTPS access. And a web server is just like everything you go to. I mean, this is a web server. And then you hit create, and it gives you an estimate over here. Hey, that's going to cost me $57 a month. And so you go, whoa, I don't want to spend $57 a month. Then you go over here and you say, maybe I want to choose, a cheaper system. And we'll go down to micro because I don't really need to do anything. And then you can be $7 a month. So, there's different prices of how you want to do. Now, if you need a GPU, then you can add a GPU and you'll see all of a sudden this goes up a lot more than the 57. We won't go through that, but there's a price to pay for everything you run. Now, if you're only going to run it for 2 hours, you pay for the 2 hours, you turn it off. You're not paying for this $7. So you get to, a penny an hour. So you could run something for a couple hours for a couple cents and move on. So it's really inexpensive. If you leave stuff running and it's bigger, then that's where you can actually spend a little bit more money. So that's kind of the basis where the cloud started, where you end up with just spinning up these VMs. And then as things went on, you got all these other services. One of the other primary things that happened was cloud storage. Now this is kind of cool. So cloud storage, and you'll notice we have a lot of stuff here, is a way to store documents, and you can hear it called object storage. In Amazon, you'll hear it called S3. And you have this concept of buckets. And so here I already have a CC Void demo bucket. We'll just click on that one. And you'll see within this bucket, there's nothing. But if you wanted to put files in there, you put files in there, you store them, you can create subdirectories just like you would. You know, we can create a folder, my stuff, and there's my stuff. And so you just have this. Now, what's really cool about this is you could actually go and turn this bucket into a website, and you just put your HTML documents up there, and then you have it. And what's kind of interesting, if you go to the docs for Cloudy Cluster, that is actually residing in a Google Cloud bucket, and we're using a static site generator to create this. And you can have everything, from images to whatever. You can embed videos that are sitting on YouTube. And you can do a lot of interactive stuff that you normally wouldn't think. And we even have a blog. You can put stuff. We can go over, and that's also sit in this static. So there's a lot of interesting, cool stuff that you can do in object storage. Now, the one thing you have to remember is keeping your private stuff private and your public stuff public. So if you're going to make a website, I'd put it in a different bucket than, your top secret files that you're trying to, solve the world's problems with. So those are the two basic things as you're kind of going into this hackathon to kind of understand, is there's computation and then there's storage. And what I want to kind of continue on with is show you a platform that we've created called Cloudy Cluster that allows you to build a high-performance computing system on top of Google Cloud. And it uses those same VMs that we launched manually, kind of showed you, but you can automatically deploy things. So what I want to do is just kind of walk you through the slide deck to help you kind of get an overview. And then we'll quickly go in and just kind of show you around. And I'll show you a way that you can actually go play on your own. The whole concept is to create a high-performance computing environment. A high-performance computing environment, if you're not familiar, and you don't have to be familiar to participate in hackathon. And the whole point is to learn and use the tools that make sense to solve the problem. And you have your mentors and your teams, and so don't let any of this intimidate you. The hackathon is to come and learn. But the whole point is to automatically deploy that high performance computing environment. A high performance computing environment is really a set of instances that are running and pre-set up for you, where you can take something called a job script. Now, job script is really just a shell script, and you can look that up, but there's a lot of canned ones you can use that really just enables you to define a workload that you want to run on a bunch of computers. So let's say you're wanting to process through a whole bunch of data, and you start looking at it because you're trying to sort it, filter it, do something, and it's going to take you 4 days to do it. It's like, well, if I use 8 computers and break up the data into 8 pieces, then it's going to take 1/8 the time or 1/10 the time if you have 10 computers, et cetera, et cetera. And that's the whole concept for parallel computation. And HPC and HTC are just forms of that parallel computation. High performance computing is kind of sometimes a general term, which means parallel computation. Other times it's a specific term that uses specific technologies that you may or may not need for the hackathon. And HTC is kind of the same thing. It's just more for high throughput versus high performance. But you don't really need to understand those. Feel free to go and look up on Wikipedia and Google those terms. One of the nice things about Cloudy Cluster is when you get these instances, you get it all set up for you. And for example, right now, here's Cloudy Cluster that I deployed before. It takes about 20 minutes to deploy, and I want you to all sit and watch the paint dry as it's spun up. And here's the login scheduler. It actually creates one of those buckets that we created automatically, and it has the control node, which is really just running this web UI. It has a parallel file system. And we showed you object storage before. A parallel file system is more of a high performance file system that looks like what you get on your local workstation. And you do your standard Linux commands if you've seen them, or in Windows if you Mike Marshall always says drag pictures around, and you kind of get the same concept. And there's some networking components and those things, but you get a web UI and you can view this environment running together. And again, there's the login node, has something called Open On Demand. We'll show that in a second. And then it's got a scheduler, and the scheduler, I told you about that job script. Its job is to go out and say, okay, I need 10 compute nodes for this. You asked for it in your script. I'm going to go out and send the work over these 10. We have a little piece in the middle called CCQ that spins those up for you, but really you're just distributing the work over those 10 nodes. And then each one of those nodes has access to this parallel storage, and the parallel storage is designed to have a whole bunch of things beat on it at once, and it doesn't fall over. And it can service requests a lot better. And those are just mounted under your normal file system, /mount/orangefs, and then you can save data there, and then the other computers can see it. So you can write stuff in other nodes, read it, and as part of this process if you need it. So that's kind of that overview level. I left some slides in here where you can see how to deploy it and launch it. You can go into the console, and what's really cool about the Google console is, let's say you don't know what you're looking for, it's there. You can say, oh, hey, there it is down there. They do a really good job of letting you search for things in the console. And so right here is, you can actually just launch a Cloudy cluster. And you can go through, set up your environment. There's a security account that you have to create. And then you can go through that. But I won't walk you through this because we're going to have this all set up for you during the hackathon, and I'll give you some ways to go review that in the future. But now that you have this environment up and running, I want to show you real quick before we get into some more details on the demo, here's some online training. This is a new thing we put out with Google where you can actually launch Cloudy Cluster and play with it and go through this self-paced, using the actual console, setting up the security, launching everything we did. And you can see it's all in detail there. And there it goes, spin it up. There's the environment. And then there's a review. And then we actually go through launching jobs. To give you an example, here's a job script. It's very simple. So this is for Slurm, because that's the scheduler. That tells you the number of nodes, number of tasks per nodes. And then here's this, it's going to have two processes for this job, and it's going to do something called MPI prime. So it's going to divide MPI prime across two cores running on a single node, so it runs it faster. So it's kind of dividing that work. So that's an example. So you can go play with this and run this. And the even cooler thing about this is if you're a student or any kind of affiliation with a university, you can actually go and apply for QuickLab credits, and students get 200 QuickLab credits. And to give you an idea, this QuickLab for, is a 5-credit thing. So 200 is a pretty decent amount of credits. And faculty members can have up to 5,000 credits to distribute in their courses. So, and there's lots of other QuickLabs in here that you can go in and try different things. There's a path to go and learn more about the console. There's things where you can try to use AI tools in the cloud. So there's lots of things, and there's ways to get those credits. So feel free to go learn and explore, because that's what this is all about. And there's some cost comparisons, and there's some other things that might be interesting to look at left in the slide deck. We'll make the slide deck available to everyone. Some other cool things that have been done. And we have some videos that kind of step you through things, but I recommend the QuickLabs because it's more of a hands-on learning experience. But let's just spend a little bit of time poking around Cloudy Cluster. One of the things that we have in Cloudy Cluster is something called Open on Demand. And you find it under Access, you go down, you click on Open on Demand, and then I already have it up and running, so we won't click on it again. And what I have done before this, and it takes a couple minutes to do this, is I've actually spun up a Cloudy desktop. And I'll show you that in a sec. And then also a Jupyter notebook. And these are each running on their own instance in the cloud. So if I go connect to the Jupyter, this is going through something called Jupyter Hub. And then we get the spinny Jupyter thing. So here I have Jupyter Notebook, or Jupyter running. I don't have a notebook open, but you can upload and set up any notebook that you want in this. And I know in some of the data science things, we'll be covering those. But what's really cool about this is in that shared directory within Cloudy Cluster, you have a home directory. And in that home directory is all of your files. So if you put notebooks in here, if you download libraries to set up a Jupyter notebook to interact with it, it's all saved. So when you launch another interactive session, it's always there. So, one of the things when you launch a Jupyter session, you say, okay, I want this to run for how many hours? If I'm going to be working for 3 or 4 hours, set it for 3 or 4 hours. The instance type. If you're not doing anything big and fancy, just set it up to an N1 standard one. And that has, 1 vCPU or 2 vCPUs. It's kind of, we showed earlier, those different instance types. And you can also do multiple instances if you need to, if you want to interact with 2 things, but generally for Jupyter, you just want 1. And if you need a GPU because you want to do some training, remember, there's a significant cost. It goes from, pennies an hour to $3, $4 or more if you're doing an A100. And you have to choose the right instance type that supports GPUs if you need that for your project. If you want to do some training through the Jupyter Notebook, if you've got some sort of neural net thing, this is a way that you can spin something up, but make sure you have enough time that you can complete everything if you're doing that, because you don't want to kill training halfway through. Because you can always kill it. You could set this longer and you could come in and just kind of go back to my interactive sessions. I can always kill this. So I can let this run for 12 hours. And then when I know I'm done, I can come back and terminate the session to save, some cost to that. To give you an idea what you can do with the Cloudy desktop is this is actually a remote VNC session into a different compute instance. And yes, I would like stuff to be able to copy to my clipboard. And so this is a full Linux, desktop that you can essentially interact with. And if you need to run some software like Paraview or something like that, where you're interacting with, visualizations, this is where you can run those types of things. And again, it still has full access to your home directory, the same thing that, here's all the different things. And if you go back to your Jupyter lab session, that's the same home directory. So you can, the data is all shared between all of this, and you can access it. And that's one of the nice things that HPC environments provide, is that you can access the data from all the different locations. And one of the other things you can do on top of this is if you want to just kind of just straight out browse the files, you can do that. And if you don't like all these windows and stuff, you can actually just open up an SSH session. If you can remember your password, you can get in. And again, it drops you in that same shared home directory that's right there, so you can access everything. And you can see where it is. Let's go back. One of the things I created this.
Boyd,
Yes.
I'm sorry to disturb you there, but would you mind hitting your Command plus or Control plus to?
Oh, you want to see? You want to see what I'm
I
typing?
would like to, but it's optional.
How's that? Is that better?
Thank you. Yes.
So there we go. There's current directory. You can ls. And so what I want to do here is, and I think we have enough time, is just run a little HPC job. So let's go. Software. And of course, I did not set this up to. I'm putting this on the shared directory. So all the nodes, when they spin up, can see it. You know, when I'm looking at /software, that's local to this specific instance, which is the login node. That's the one you're kind of interacting with when you're doing a lot of this work. And I want to copy it to the shared file system. So every node can access it when I'm doing it. So there, it's sitting out there, and we're going to go down under MPI. There's some other, you know, OpenFOAM and WARF. There's other sample jobs sitting out there, but we'll just go kind of that one I showed in the Quick Lab. And the Quick Lab actually goes through the same process. And so we're down into the GCP directory to kind of show you where we're at. Again, Mount OrangeFS sample jobs, MPI, GCP. That's what we copied up here. This is CP-R. I was telling you to use a capital R because the little r had some bugs and that they had to keep it compatible. And then it's copying everything from sample jobs, and it's going to create the sample jobs directory and dump the contents, and the -R is recursive. So it's going to go through and roll through everything. So it's all sitting out here. So when I do an ls, there's an MPI prime compile. So there's an MPI prime program in the parent directory. We'll just show you that. So there it is. So there it is. Now we got to compile this. Since that's sitting up here, we'll do MPI. And this is just a script that compiles it. It does nothing special. I guess we can show you it. So there it is. It's just going to use OpenMPI. You can switch it to MPICH if you want, or you can switch it to Intel MPI, but we're just going to use OpenMPI because it's the default. And then when we actually are going to run an MPI prime job, which is going to, well, let's go ahead and look at that. So we're going to vim. So here is a batch job. So the interesting thing is about a lot of these batch jobs is comments don't always mean comments, but double comments always mean comments. So actually anything with a single comment is going to be looked at by the scheduler, and we're using Slurm in this case, to see if it's something it should do. If it's not, it'll just ignore it anyway. But these two commands we want to. So we want to launch 2 nodes, and we want 2 tasks per node. And we're going to let Cloudy Cluster pick what nodes it wants. We don't care because it's just an MPI prime thing. It's going to, you know, knows that Mount OrangeFS is the shared home directory because we have this variable called, you know, shared FS name. And if you notice down here, we're going to change directory into the shared FS name, and then we're going to go down to sample jobs, and we're going to go under MPI. And then we're going to do something called an MPI run, which is one of those, I want to run something on multiple nodes commands. Google it, read more about it if you want, but that's what that does. And the one thing we're going to do is notice this OpenMPI here. This matches the OpenMPI from the compile, because when you want to run, you want to have the libraries that support it match to what you're running. So these have to match up, and you can read more about different MPIs if you want to get into MPI, if you want to try to do an MPI job, but you're probably not going to learn MPI and run an MPI job within the time frame of the hackathon unless you have prior experience. There's other ways to do parallel things that are easier. You can launch separate nodes to kind of do the processing in parallel a little more manually. and it's a lot easier just to kind of do. So
I
don't.
would like to add one thing to that for everyone listening. So for the students and mentors, if you don't already know, by actually being a part of HPC in the city, Exceed, Sura, TAC, and the Inclusivity Committee of Supercomputing 21, so all of those entities together, will actually be ensuring that you will be registered for the Supercomputing 21 conference. So all of that to say this, there is a fantastic MPI, so that message passing interface for parallel computing tutorial and workshops that are held at SC every year. So you may want to take a look at the schedule and see if you could participate in one of those if you're interested in learning more about it.
Yes, thank you. Yeah, and MPI is something that you could learn to do some stuff ahead of time before the hackathon, but you're not going to learn it within the time frame is what I was getting at. But yeah, there's wonderful tutorials and take advantage of them. And there's good information on the web too. But this is something that, I showed you that C program, it already uses MPI. If we had a little more time, I could walk through that. But let's go ahead. We've got the MPI run. The number of processes is 4. Now we have 2 nodes, 2 tasks per node. So that's 4. So it's going to say, okay, and this MPI prime job knows that, okay, if you're passing in, I'm going to be running on 4. So it's going to break up the workload across those 4 things. Let me make sure I did everything right. And then we'll just submit the job. And CCQ sub is CCQ is a meta scheduler, and I'll talk about that in a second. Let me just run the job because it takes a minute to spin things up. And so we're going to actually run that. So CCQ is a meta scheduler, and that submitted the job to the meta scheduler. The meta scheduler is actually going to spin up those 2 nodes. If it were 20 nodes, it would spin up the 20 nodes. And then it's going to release, when there's all up and they're configured and they're ready, it's going to release that to Slurm. CCQ already registered those nodes with Slurm, and Slurm's going to be sitting there saying, okay, I know about those nodes, and it's going to release the job once it's ready. There was also another thing called CCQ stat. And there you can see, notice those open on demand things. Open on demand, we worked with the open on demand group to actually integrate CCQ so it knows and understands CCQ. So when we're looking at those interactive sessions, the Jupyter or the desktop, wherever it's hidden, those are actually those jobs sitting there. Now, what's interesting is Open on Demand also has the capability of you can look at jobs. So if you want to look at this from a GUI approach, you can do that. So here are those same jobs running. This is the MPI prime, it's queued, but there's these other interactive sessions that are running without any issue. And you can actually, there's actually a job composer that you can go through if you really like the GUI concept. You can go through and interact with this and create jobs yourself and save them and do things like that. It's actually pretty cool. We won't walk through all that right now because you have to, it tells you about everything the first time through. And I just launched this. So there, and you can also go into the file manager and there's options to edit files. So if if I would rather go back to different places and, go back here, if you really don't like doing all that Vim stuff that I was doing, here's that MPI prime SH. If I click on edit, it brings up an editor. So you can do this all in the browser if you want. You can edit you want and then hit save, but there it is. It's single comments. It's that same file in that same shared space. And again, the power of shared space is really, really kind of cool because you don't have to worry about how to get this thing from here to there. And that's one of the, HPC systems kind of have solved that problem and bring that to you. So let's go back to my command line. There we go. And see, so it spun up the node. Now it's provisioning. That means it's taking care of the final things. If you don't like typing CCQ stat all the time, you can just watch it. And we got the job being submitted. Now the job's completed. So that job ran on 2 nodes, spun up the nodes, did all that in that amount of time. And now what's kind of cool about that, even if you go to this console, you can see those. And you can see that actually it's been an hour since I launched these other interactive sessions, and they're going down just like I set up. So I probably started those about 10 minutes before the hour. But here's the 2 nodes for that HPC job. And if we go to this session, since it's completed, break out of that. And one of the interesting things, let's do that this way. So go back to the home directory. So here's an MPI prime error, and here's the MPI prime output. So if we view the output file, so using 4 tasks to scan a couple of numbers, the largest prime was pretty big, and the total number of primes were that. So it processed that in 4 seconds. If you run that on a single core of the same type of machine, it will take more than that. And if you run it across more machines, the time will decrease until you get to diminishing returns, where communicating between them doesn't reduce the time. But that kind of gives you the idea. But so here we ran a job. And again, if you want to try this yourself, go to the Quick Labs and give it a try, because you can actually walk through everything I just did as part of that Quick Lab. The one thing to remember with the Quick Lab is, you can't go off, because
for my gamers, it's not an open world lab.
Yeah. Anyway, you only have the 7 instances that it spins up. And if you spin more than that, your account gets locked and they have to go clear it. So you have to stick to the script and stay within what it does. And stay on the nature preserve or whatever. And anyway, so that's it. That's kind of an overview of Cloudy Cluster, overview of Google Cloud. Always, if you have questions, feel free to reach out. And if you have questions, ask.
Excellent, excellent. Boyd, amazing job. Amazing job. And thank you for putting up the slide, because that was exactly what I was going to do. So I do want to say, for those of you that were listening, you may have heard some terms that if you're not used to the high performance computing world or have worked with Google Cloud before and things like that, many of those terms and things I've actually added to the chat session, and I think I may even include the chat session in the when we upload the video, so that if there are any of those terms you're like, do what now, like CCQ, Slurm, clusters, wall clock time, jobs, nodes, all those things, I've kind of included them inside of chat, but I will ensure, as a matter of fact, let me make sure right now, save chat. Of course, you can do the same thing, but that way we'll have that information. Again, Boyd, thank you. Amazing job. Cloudy Cluster. First of all, Omnibon has been a constant supporter of the hackathons for 4 years now. They have provided funds for our students to both attend conferences, as well as this upcoming conference, Cloudy Cluster. The Cloudy Cluster and the Omnibon team provide mentors, staff, And most importantly, for our competition, they actually provide those cash prizes that we have at the end. So I just want to take a second and give them a hand and say thank you. Thank you so much. To give you an idea of just how much impact Omnibond and their team has on this hackathon, Boyd just gave the presentation. Amy Cannon is also here on the organizing committee. Josh Kissel does an amazing job keeping up with the main hackhpc.org website. And you'll meet many more like Cole and Mary as we go into the hackathon itself. As you see there, Boyd's contact information is there. When the hackathon starts, day one, during the kickoff, we're going to say, hey, once you have your team together, make sure your mentor sends a message to Boyd to get your Google credits so they can set up your team and send them to you. Extremely important. So Boyd is the man. That's what it is. He's the man. It is what it is. Having said that, now that we've completed our Google and Clouded Cluster training, we have only two pre-event training sessions left. I know it's coming up. I need to take naps too. I get it. But we have our next week with Lisa Pearson from TAC, one of our programmer extraordinaires and dashboard extraordinaires will be adding a new training session for the first time this year called Data to Dashboard. Data to Dashboard. This is a session we have been waiting for because the majority of the teams that have imported some type of data, they want to output it in a beautiful way. And that's what she's going to allow you to do. And she's going to show you how to do that. After that, we have another very special training session, which we all, and by we, I mean the returning mentors and the organizing committee are so looking forward to. And it's our training session called Beginning to End Project Example, which is kind of, you just, but that's not the thing that we're excited about. The thing we're excited about is one of our own participants. She started off as a entry level, and by entry level, I'm gonna tell some of her business. She'd been coding, or she had coded her first anything 2 weeks before her first hackathon. 2 weeks. That was 4 years ago. This year, she's returning as a student mentor for the third time, and she's going to be showing how she created one of her projects from the beginning to the end so that it gives you a real idea of what this will be like. Now, the sound of the beep, we've officially hit 11 o'clock a.m. here Central Time. So with that, we are concluding our presentation for today. I want to give Boyd one more hand. My fellow organizing committee, I want to give them one more hand. And with that,
and give Jamie a hand.
Thank you all. And with that, I'm actually going to stop the recording, and you all have a good day.